So it's that time of year once again to build a Christmas decoration, and what I've got this year is this nice little kit that I got from Aliexpress. The kit itself was less than £1, but actually the postage was extremely expensive, so in the end I got 2 of these for about £3, just over £3. But I really wanted to build this one because it's a nice little kit. So you see it's got a single integrated circuit here, so the LM358, which is a dual comparator, and we'll look at that in a second. And there's some capacitors and resistors on this side, but then you can see on this side you've got a whole load of surface mount LEDs. So 16, I think it is. Yeah, so about 4 on each span. So 16 LEDs. The on the website it looks like they're red LEDs, but I'm going to do a bit of a mod on this. So these are probably red ones supplied with it. But I've got this pack here which is flashing LEDs. So I thought I'd put some flashing LEDs on there to add a bit of extra interest. And so this is using the LM358, which is quite a common thing used in these LED kits, and so it has an effect that they call breathing, where basically it fades up slowly and then it fades back down again. And inevitably, when you see kits that have this breathing functionality, you have the LM358. Now there is a schematic supplied with this one. The instructions are in Chinese, but I don't think it's very demanding in terms of knowing where to put things. But here's the schematic. So if we just kind of roughly try and understand what this circuit is doing, obviously over here you have an output transistor, a current limiting resistor, and then here are the LEDs. So all the LEDs go through this single current limiting resistor. So this is the the power route for the LEDs. And then this here is the 2 comparators. And so first of all, if we have a look at what's happening here, so we have a resistive divider here, 247k resistors, which means that this pin 6 here and the pin 3 onto the 2 comparators, this is being held at halfway between ground and the supply rail. So this will be about 2.5 volts, something like that. Now on this side, what we see is the LM358. The output is wired back to the positive input, so that means that's a positive feedback. So basically, if this ever becomes positive, then this will lock on, the output will be positive, and then that further reinforces its own input, so it will remain positive. And likewise, if this ever becomes negative, then the output will go negative, and therefore it will reinforce the negative on its own input, and so it will be hard over on the 0 volts. So the result of that is, at this point here, we have a square wave coming out, and maybe we can look at that using the oscilloscope later when we've assembled it. Now this is this second one is actually for producing a triangle wave. So this is what's at the heart of the breathing effect. So in this case we have the square wave output is going into that negative input, which means that whenever this voltage is higher than that voltage, remember the halfway 2.5 volts voltage, so if the minus ever gets beyond 2.5 volts, then this will start to go low. So this will invert, and because we have a capacitor in this loop here, what ends up happening is this capacitor will charge. So we have a resistor and a capacitor, so an RC network here. So this can provide the current to the capacitor to start making it charge. So you should start seeing a ramp increasing like that. And then at some point when this reaches the threshold, when it reaches the 2.5 volt threshold, then what will happen is this capacitor will now start to discharge, and so you'll get a ramp going back down the other way. So what we should end up here with here is the triangle wave, and that's the basis of the breathing effect. Now this RC pair, this will define the actual time that it takes to do that charging and discharging. And what we can do is we can multiply the 47k by 47 microfarads, and actually if you do the calculation, the RC constant ends up to about 2 seconds. So I would expect this breathing effect to be 2 seconds charging and then 2 seconds discharging. But again, we'll see. Maybe we can see that on the oscilloscope. I might have to put a smaller capacitor on there because my oscilloscope doesn't necessarily do low frequencies very well, but we can look at that. As I say, a very common type of kit, but this one's nice because they've gone to the trouble of making it into a little star so it can be a Christmas decoration. So the big challenge here, as ever, is going to be these tiny surface mount components. So I'm going to have to place all of these tiny LEDs, and if you've watched my previous videos, you'll know that I'm not a huge fan of dealing with these tiny components, but we'll just have to work our way through that. So I think what I might do first of all is just set up a voltage source with a current limiting resistor, and then we can poke some of these LEDs and see what colours we've got here, and check that we've got the flashing effect. And while I'm at it, I'll have a look at these and make sure that these are red LEDs. So let me set that up and we can do a little bit of testing. Alright, I've got something set up now. So I've got a 330 ohm resistor. This was actually one of the ones that was left over from the last build. So 330 ohms, and this here, I've got a capacitor here, but I'm just really using the wire. So on this side we've got the flashing LEDs that I ordered, and on this side we've got the ones that came with the kit. So let's have a look. I've got 5 volts here, by the way. Should be enough to light these LEDs. It's a little bit tricky testing these surface mount LEDs. I can't see any current draw there. Maybe it's the wrong way around. Let's have a look. Whoops! They do tend to ping off because they're very light. Oh, there we go. Right, so these are yellow. Yellow's good. Yeah, I like yellow. So we're going to go for the yellow flashing ones. Let's just have a look at what these other ones do. Okay, and I may be the wrong way round. Oh, there we go. Green. I'm not sure if that shows up quite so well on the camera, but it looks very green to the eye. So actually these are not red ones like in the listed on the website. They're green, so that's probably quite a nice effect. Now I've got two of these kits, so I may well build one with the green LEDs in as well. But anyway, so that looks like it's feasible to use my flashing LEDs, so I will go ahead and do that. Right, I've discovered that I don't quite have enough yellow LEDs to complete this, but what I do have in the flashing LEDs that I ordered, I also have orange LEDs, so what I plan to do is alternate between orange and yellow, and I'm sure that will be fine. So let's start putting these LEDs in. I'm going to try putting a bit of extra flux on here. So I was having some problems when I was doing that previous kit. There were some bits of the board that weren't taking the solder very well, so I'm going to try and put a bit of extra flux on there. Right, so this, with the little green tab, should be the cathode. So I think if I put it on this way, that's going to be right. Just try and hold it in place. Okay, that seems all right. That's the first one. Let's have a look. Yeah, I think that will do. Oh no, I just squeezed the lead and it pinged off. I don't know where it is now. Oh well, hopefully I've got enough here to complete the job. Okay, so I think that's that one, that way there. Anyway, I won't bore you with showing you assembling all of these LEDs. You can see the basic principle that I'm using, so I'll just skip over to the end here for you. There we are, so I've got the yellow LEDs in place, and the remaining gaps I'm going to fill in with the orange flashing LEDs. So we should actually be able to test this now and see if the LEDs will light up. So the same configuration as before with the current limiting resistor. So if we can reach in and connect one of these, then we would expect all the LEDs to light up. There we are. You see there's a bit of a random element to it, because although they start flashing all in sync, they'll have slightly different timers in them. So after a while they've all kind of drifted out and they look a bit random. And if you've seen Big Clive's videos. I know Big Clive likes to build these panels with self-flashing LEDs, which kind of look like futuristic computer kind of things. So there we go. I mean, in my case, if that ramp up, ramp down time is only about 4 seconds, we probably won't see much variation. But we'll just have to see what the effect is like. Right, so I'm going to fill in those gaps with the orange flashes now. Where are those? There, orange flash. So we'll fill in those gaps and then we can do another test in a minute. A bit more fiddling about, and I've got the orange ones in place now. So let's have a look at that. Let's get the right end of the resistor. Don't want to blow my LEDs up now. There we are. My thumb's a little bit in the way there. Let's see if I can do that better. There you go, that's quite pleasing. Now for some reason the orange ones seem to be out of phase with the yellow ones at the beginning. They wait before they light, which is quite nice actually from my point of view. So you see that the orange one lit first and then the yellow one, and then of course they all gradually drift out of synchronization. But that sort of alternate flashing was unexpected and a nice accident. Right, so that's the LED sorted, so it's just a question of putting the other components on the back now. So starting with the chip and then working out to put the capacitors and resistors in place. Right, I'll try and get this chip in place. Let's see if not sure if there's actually any flux still in my flux pen. Doesn't seem to be. The end's stuck now. It does feel slightly moist. Have to buy another one. Anyway, let's try and get this chip in place. So the usual procedure, just try and tack down one corner and then try and position the rest. Just check that with the magnifying glass. Looks fairly good, I think. Okay. Do the second row. I find I've been finding with these pins very close together, it's actually easier to put a little bit of solder on the end of the iron and then just try and wipe it on the track. Oh, I've got a bridge there. Okay, that looks good. I think we're there for the chip. So a few other ancillary components now. Some resistors and just the one capacitor? Yeah, just the one. So let's put the capacitor in first. See, today I'm using this using the Scotch tape to keep everything in place because it's a very light circuit board, but also I can't find any blue tack. Right, what have we got in there? Oh, those are transistors in there. I think I only need the one transistor though. They seem to have provided two. These are all resistors. And here's the capacitor. I think it's really amazing how much capacitance they can get into these tiny surface mount components. I think they're made with tantalum, which is a very rare element. Now I can measure the capacitance on my meter here. Let me just have a look at that. That says 33 microfarads. Just not quite was on the circuit diagram, but it's fine. Take that into account. That'll just mean the flashing is slightly faster, I guess. Or fading, should I say? Because this is what controls the breathing effect, the rate. Okay, right, so we've got a couple of, well, 3 47Ks, so that must be that one there. Yeah, so these are marked 473, so that's 447 with 3 zeros. Let's try and get these in place. Okay, so this one here is 220 ohms, so that'll be the current limiting. So this one's marked 220. Right, so this one's marked 104, so that's 10 with 4 more zeros, so this is our 100k value. And then hang on, I've got a space there, haven't I? What's that say? Oh, 33k. Let's have a look. Got one here. And this says 333. So 33 with 3 zeros. And then the last component is one of these transistors. Which goes on the left hand side there. Let's just get it the right way up. Oh, I think I got a bit of solder onto that top pad by mistake, so it's a little bit difficult to get into position. Yeah, that'll do it. Okay, that's all the components in, so let me do a little inspection. This one's not very pretty. think there's a reasonable chance that will work. Shall we put 5 volts in? See what happens. I can see it's doing something. It does rather seem to be permanently on though. Alright, let me solder these. So they gave us a couple of little wires. I'll solder those on. That'll be easier to power it, won't it? Oh, come on. It is doing something. Let me just switch this extra light off here. Yeah, I can't really see any, can't see the breathing effect. I quite like the randomness of it though. Yeah, I might have to get the oscilloscope on there, I think, and see if there's any activity on the chip. To make it easier to see what's going on, I took off the surface mount capacitor. I've soldered on a discrete one. So this is a electrolytic capacitor, 1 microfarad. So that's much smaller than the 47 value that's supposed to be on this circuit. Which should make the rate higher. So I was hoping to be able to see the waveforms on the oscilloscope. Now, before I connect it up, I should warn you that this is going to flash quite fast. So this is a strobe effect. Okay. So if you don't like that, then please look away. There we go. So that with that capacitor on, you can see it's really flashing quite madly. So that's the combination of the natural flashing of the LEDs and this more rapid flash from the smaller capacitor. So I'm going to try and get the scope in here now, and we'll see what we can see on the oscilloscope screen. Right, so here we go. I've got one probe attached to the capacitor. So I've got this smaller value capacitor. This is 1 microfarad. So that's smaller than the normal surface mount component there, because I wanted to get the rate up so that I'd be able to pick it up on the oscilloscope, because my oscilloscope doesn't do low frequencies very well. So that should be around 20 Hertz, I think, from the calculations I did. And then I've soldered this other wire on here onto one of the resistors, so it's actually on the on one of the outputs of the LM358. So basically I've got the upper trace on my oscilloscope looking at pin 7, and the lower trace, so the other probe is on pin 1. So if we have a look at that output on the oscilloscope, on the bottom here, so you can see the triangle wave coming out of the right hand LM358 output. So you can see quite a nice triangle wave. It actually takes longer to discharge than to charge, which is quite interesting. Not quite sure why that is. And then this is the output of the left hand LM358, so this is producing more or less a square wave pulse, but because these are working together, basically the square wave, or I mean it's like it's got less a smaller charge time than it has discharge time, so it's not quite symmetrical. But basically, when this goes high, this is starting the discharge event, and when it gets low, it's starting the charge event. And because the output of the left-hand LM358 is charging the capacitor, then this defines the output of the second LM358. So basically, we've proved that we're getting a good triangle wave, and therefore the circuit should be working. So I think the next step will be for me to put back in the old component, the surface mount component, and see if I can get the effect that I want. When I was desoldering that component, it did look like it might be bridging the two pins together, so maybe that was the problem. So I'll reassemble it more carefully. Okay, so I put that capacitor back on, so there's clearly a gap there now. It's properly mounted, which it may not have been in the first place. And actually the effect is quite pleasing now. So you can see it does actually fade in and out, and then when it's faded in, you've got all the various orange and yellow LEDs flashing. I'll just put this light out actually so you can see a bit better. Maybe put that light on now. So I'm very pleased with that actually. I think that's a really good modification. So it's added a bit of interest. So rather than just all the LEDs fading in and out, it's actually doing something more random, more interesting. So there we go. I will leave that there. Another year, another Christmas decoration. So thank you very much for watching, and if you've been watching my videos throughout the year, thanks very much for following along, and do all have a Merry Christmas and a Happy New Year.